March 15, 1967. Haifa Naval Base, Israel. The engineering officer read the classified memo for the third time. Naval headquarters had rejected his proposal again. Missiles on small patrol boats violate established naval doctrine. Request denied. Commander Yosef Barkai crumpled the paper and stared at the 5 German-built Jaguar-class patrol boats tied to the pier. 115 tons, 42 meters long, armed only with twin 40mm cannons. What none of the admirals understood was that these wooden boats were about to become the platform for a weapons revolution that would sink destroyers in the first successful anti-ship missile attacks in naval history, fundamentally transforming surface warfare for every navy on Earth. The Egyptian Navy owned the Eastern Mediterranean. Since the Suez Crisis of 1956, Soviet-supplied warships had transformed Egypt into a regional naval power that dominated the waters between North Africa and the Levant. Their fleet included 7 destroyers, 12 submarines, and most significantly, 8 Komar and Osa-class missile boats, armed with Styx anti-ship missiles. President Gamal Abdel Nasser had declared the Gulf of Aqaba closed to Israeli shipping. Egyptian destroyers patrolled international waters with impunity, their presence a constant reminder of Egypt's naval superiority. Their Soviet P-15 Termit missiles, NATO designation SSN-2 Styx, could strike targets at 40 kilometers with devastating effect. Their destroyers displaced 2,000 tons and mounted 130mm guns with 15-kilometer range that could reduce coastal installations to rubble. Their crews had trained at Soviet naval academies in Leningrad and Sevastopol, learning advanced surface warfare tactics developed through decades of Cold War naval competition. Israeli patrol boats, by contrast, carried guns with maximum range of 4 kilometers. The strategic calculation was brutally simple and mathematically devastating. Israeli boats had to close within 4 kilometers to engage enemy vessels with their conventional weapons. Egyptian missiles could kill them at 40 kilometers, 10 times that distance, without air superiority, which Israel could not guarantee at sea given the distances involved and the limitations of air patrol endurance. The Israeli Navy faced strategic obsolescence. The mathematics of naval combat had turned decisively against them. Admiral Yohai Ben Noon's fleet consisted of aging destroyers purchased from Britain and France, 2 submarines of questionable operational readiness, and patrol boats designed for coastal defense against smugglers and infiltrators. None could challenge Egyptian missile boats in open water. None possessed the range to engage Egyptian destroyers before being destroyed. The naval staff had concluded through systematic analysis that surface warfare against Egypt was strategically untenable, given the current force structure and weapons inventory. Israel would have to rely entirely on air power for naval defense, accepting that the Mediterranean coastline would remain vulnerable to Egyptian naval bombardment whenever weather or operational circumstances prevented air coverage. This was an intolerable strategic weakness for a nation whose major cities lay within 20 kilometers of the coast. Tel Aviv, Haifa, Ashdod, all were vulnerable to naval gunfire. The Israeli Air Force could not maintain constant air patrols over the Mediterranean. Gaps in coverage were inevitable. During those gaps, Egyptian destroyers could approach the coast and shell civilian populations with impunity. Commander Yosef Barkai had spent 6 months developing an alternative solution, working nights and weekends in his small office at the naval base, covering drafting tables with technical drawings and mathematical calculations. An engineer who had worked on France's missile programs before immigrating to Israel in 1962, Barkai understood that the technology existed to arm small boats with guided missiles. He had witnessed French experiments with anti-ship missiles at the Toulon Naval Facility. He had studied American developments in guided weapons. He knew the fundamental physics and engineering principles. The problem was not technological feasibility. The problem was institutional resistance, rooted in centuries of naval tradition and doctrine. Naval doctrine, established over centuries of maritime warfare from the age of sail through 2 world wars, held that missile systems required large platforms with sophisticated fire control, extensive crew compartments, and substantial electrical generating capacity. Destroyers and cruisers carried missiles, patrol boats carried guns. The hierarchy was absolute and unquestioned. Ships were categorized by displacement and armament. A vessel of 115 tons was a patrol boat, suitable for coastal defense, harbor security, and anti-smuggling operations. Such vessels did not carry strategic weapons systems. The suggestion that they could do so was considered technically ignorant at best, professionally irresponsible at worst. But Barkai had studied the physics with an engineer's precision and lack of reverence for tradition. A missile didn't care what platform launched it. The missile had its own propulsion, its own guidance system, its own warhead. The launch platform merely had to provide initial velocity and targeting information. If you could solve the technical challenges of mounting, targeting, and firing a missile from a small boat, specifically the challenges of weight distribution, structural reinforcement, fire control integration, and crew training, you could transform coastal patrol craft into capital ship killers. You could give small boats the ability to sink destroyers. The implications were revolutionary, and that was precisely why the naval establishment rejected the concept. The Israeli Defense Forces had recently acquired Gabriel anti-ship missiles, indigenous weapons developed by engineer Dr. Ori Eventov at Rafael Advanced Defense Systems in Haifa. The Gabriel represented Israeli innovation born from absolute necessity. Israel could not purchase advanced weapons from major powers due to arms embargoes and political considerations. They had to develop their own systems or accept strategic vulnerability. The Gabriel missile was the result of 5 years of intensive development. Length 3.3 meters, weight 400 kilograms, range 20 kilometers initially, with potential for improvement. Solid fuel rocket motor, providing thrust for 60 seconds. Active radar homing seeker in the nose cone. High explosive warhead, weighing 150 kilograms. The missile had been designed specifically for land-based coastal defense batteries, positioned along Israel's Mediterranean shoreline. Military planners at Southern Command and Air Force headquarters assumed the Gabriel was too large and complex for small boat platforms. The mounting requirements seemed prohibitive. The fire control systems seemed too sophisticated for patrol boat electrical systems. The guidance radar seemed incompatible with the navigation and communication equipment already installed on small vessels. Most critically, the recoil and blast effects from missile launches seemed certain to damage or destroy wooden-hulled patrol boats. Every technical analysis conducted by naval architects and weapons specialists concluded that mounting Gabriel missiles on SAR-class patrol boats was impractical and potentially dangerous to the crews who would operate such modified vessels. Barkai's proposal was technically radical and doctrinally heretical. Mount 4 Gabriel missiles on SAR-class patrol boats, vessels essentially identical to the Jaguar-class boats, currently in service, but with minor modifications for Mediterranean operations. Develop a compact fire control system that could operate reliably in high sea states, which were common in the Mediterranean during winter months, and could reach significant wave heights. Create tactics that would allow small boats to engage destroyers and missile boats beyond visual range, exploiting speed and surprise rather than armor and firepower. Train crews in electronic warfare, radar operations, and missile tactics rather than traditional gunnery and seamanship. Transform the entire conceptual framework of how small navies could conduct surface warfare. The naval headquarters' objections were predictable and, from a traditional perspective, entirely reasonable. Patrol boats lack stability for missile systems. The center of gravity will shift dangerously with top-heavy missile launchers. Fire control systems require dedicated compartments and trained specialists. We don't have space for equipment or personnel. Recoil and blast effects would damage wooden hulls. The Gabriel uses a solid rocket motor that produces extreme temperatures and pressures. The guidance radar would interfere with navigation systems already pushed to their operational limits. Each technical objection was valid, based on conventional naval architecture and systems integration principles. Each could be overcome with creative engineering and systematic problem solving, but that required institutional willingness to challenge established doctrine. Shlomo Ireli had worked as a shipfitter at Haifa shipyard for 12 years, a craftsman who understood through decades of hands-on experience how boats responded to stress, weight distribution, and structural loads. Ireli examined the structural plans for mounting missile launchers on a SAR-class hull, spreading the blueprints across a work table in the shipyard's engineering office, and spending hours with calipers and calculators. The weight distribution is possible, Ireli explained to Barkai during a meeting that stretched past midnight. We reinforced the deck with steel framing, using high-tensile steel in a web pattern that distributes loads across the entire hull structure. Mount the launchers on shock-absorbing platforms with hydraulic dampers that reduce stress on the hull during launch. The missiles weigh 400 kilograms each, 1,600 kilograms total for 4 missiles. But we remove the aft gun turret, which weighs 800 kilograms, including the mount and ammunition storage. Net addition is 800 kilograms, concentrated amidships, where the hull is strongest and where the keel provides maximum structural support. The stability calculations work if we also add ballast in the lower hull to compensate for top weight. The launch blast presented a greater challenge than simple weight distribution. Gabriel missiles use solid rocket motors that generated intense heat exceeding 1,500 degrees Celsius and pressure waves that could shatter unprotected glass and damage electronic equipment. Firing from an enclosed launcher would create back pressure that could crack wooden deck planking, rupture fuel lines, and potentially ignite stored ammunition or fuel. Traditional naval missile launchers used heavy steel boxes with blast deflectors, but such systems weighed several tons and required extensive structural support. Ireli designed open-frame launchers that directed blast upward and aft, away from crew positions and sensitive equipment. Heat shields, made from titanium alloy, protected adjacent structures. Blast deflectors channeled pressure waves safely. The solution was crude by conventional naval engineering standards, but functional and, critically, light enough for small boat installation. Fire control technology required more sophisticated engineering than structural modifications. Major Shmuel Makov, an electronics officer who had studied radar systems at the Royal Naval College in Britain and worked on early computer systems in the Israeli Air Force, tackled the targeting problem with systematic analysis. The Gabriel missile used semi-active radar homing, a guidance method that required continuous radar illumination of the target. A guidance radar on the launch platform had to illuminate the target continuously from launch until impact, typically 60 to 90 seconds depending on range. Traditional naval fire control systems occupied entire compartments below deck with analog computers weighing hundreds of kilograms, multiple radar displays, dedicated plotting tables, and teams of trained operators working in coordination. Makov's solution was radical miniaturization, inspired by aircraft systems. He adapted radar systems, originally designed for single-seat fighter aircraft, specifically systems developed for the French Mirage fighter, to naval application. The entire fire control system fit into a console no larger than a standard refrigerator, measuring approximately 1 meter wide, 0.8 meters deep, and 1.5 meters tall. One operator could manage target acquisition, tracking, and missile guidance from a single station. The system used a modified search radar, operating in X-band frequencies, to detect targets at 30 kilometers under favorable conditions. Once a target was identified and classified through electronic signature analysis, the operator switched to tracking mode, keeping a targeting reticle centered on the radar return, displayed on a cathode ray tube screen. When the missile launched, its seeker head would home on radar energy reflected from the target, following the reflected beam like an aircraft following an instrument landing system. Accuracy depended on the operator maintaining precise target illumination throughout the missile's flight, requiring intense concentration and steady hands despite the boat's motion in rough seas. Testing began in August 1967 with the first Sarah-class boat modified to Barkai's specifications at the Haifa shipyard. The boat, redesignated as a missile boat rather than patrol boat to reflect its new capabilities and mission profile, underwent extensive sea trials in the Mediterranean over 3 months of intensive operations. Initial results were profoundly discouraging and seemed to validate the skeptics' concerns. The first missile launch at a target drone conducted 15 kilometers offshore failed catastrophically when the fire control radar lost lock during high sea states. The boat's motion in 2-meter waves, combined with wave interference that created clutter on the radar display and made target discrimination nearly impossible, created tracking errors that sent the missile off course by more than 5 kilometers. The missile's seeker lost target acquisition, and the weapon flew ballistic until fuel exhaustion, splashing harmlessly into the Mediterranean. Makov spent 3 months developing stabilization algorithms, using early digital computer systems, programming in machine code on equipment borrowed from the Israeli Air Force's Weapons Development Center. The fire control system would predict target position based on observed movement over time, using velocity and heading data to extrapolate target location several seconds into the future. This compensated for the inherent lag between radar returns and missile response. When operators manually corrected for pitch and roll, based on artificial horizon indicators integrated into the fire control console, tracking accuracy improved dramatically. By October 1967, the system achieved consistent hits against target drones at 18-kilometer range, even in 3-meter seas, demonstrating operational viability under realistic combat conditions. The Israeli Navy ordered immediate conversion of all SAR-class boats to missile configuration, allocating substantial budget resources despite competing priorities. In the aftermath of the Six-Day War, production began on an additional 12 boats, purpose-built as missile platforms, rather than conversions of existing vessels. Each boat would carry 4 to 8 Gabriel missiles, depending on specific configuration and mission profile, plus rapid-fire guns for close defense against aircraft and small craft. Construction crews worked around the clock in shifts, covering 24 hours daily. Welders reinforced hulls with additional framing and plating. Electricians installed fire control systems, running thousands of meters of cable through confined spaces. Missile technicians calibrated guidance radars, adjusting frequency response and signal processing parameters. The first operational missile boat, ENS Mivtak, commissioned on December 1, 1967. By June 1968, 5 missile boats were operational and conducting training exercises off the coast. 12 more boats were under construction at shipyards in Cherbourg, France, where Israel had ordered a modified design based on lessons from initial conversions and sea trials. The French boats, designated Sarah II and Sarah III class depending on specific modifications, would be larger, at 250 tons displacement, and faster, with maximum speeds exceeding 40 knots in calm seas. Purpose-built missile platforms, incorporating design improvements rather than conversions of existing hulls. The French yards had extensive experience with fast attack craft and could deliver superior quality. However, political complications would eventually force Israel to smuggle several boats out of France under cover of darkness, a dramatic operation that became legendary in Israeli naval history. But the Egyptian Navy wasn't waiting for Israeli developments. Intelligence reports from Mossad agents in Egypt and signals intelligence from Unit 8200 indicated Egypt was aggressively expanding its missile boat fleet with Soviet assistance. Soviet deliveries included 6 additional Osa-class boats delivered aboard transport ships from Black Sea ports, each carrying 4 Styx missiles with ranges exceeding 40 kilometers. Egypt's operational doctrine, developed by Soviet advisors and practiced in exercises with Soviet naval forces, emphasized overwhelming firepower through coordinated group attacks. Their boats would attack in coordinated groups of 4 to 6 vessels, launching salvos of 16 to 24 missiles simultaneously from multiple bearings. This saturation approach would overwhelm defensive capabilities and ensure multiple hits regardless of individual missile accuracy. Israeli boats, with 4 to 8 missiles each operating independently or in pairs, would be outnumbered in any engagement where Egypt could concentrate forces. Admiral Ben Nun developed tactical doctrine that emphasized Israeli advantages rather than attempting to match Egyptian firepower directly. Speed and surprise would substitute for numerical superiority in missiles. Intelligence would identify target locations before engagement through signals intelligence, agent reports, and aerial reconnaissance. Israeli boats would attack at night or dawn when radar detection was most difficult due to atmospheric conditions, and when Egyptian crews would be less alert after long patrol periods. They would fire first, from maximum range, before Egyptian boats could coordinate responses or achieve optimal firing positions. The entire engagement would be over within minutes before Egyptian forces could rally reinforcements or organize systematic counterattacks. Electronic warfare became critical to Israeli doctrine and received priority in equipment development and crew training. Israeli engineers at Rafael and at military electronics facilities developed simple but effective radar jammers that could confuse Styx missile guidance systems through noise jamming and deception techniques. The jammers, compact enough to be mounted on small boats without significant weight penalties, would accompany missile boats into combat zones, creating false targets that appeared on enemy radar screens and obscuring real positions of Israeli boats. Chaff launchers fired clouds of aluminum strips cut to precise lengths corresponding to enemy radar frequencies that created massive radar returns, overwhelming enemy targeting systems with hundreds of false contacts. The chaff clouds would linger for several minutes, providing concealment during critical phases of attack and retreat. Training intensified through 1968 and into 1969 as more boats became operational and crews gained experience. Crews practiced rapid targeting and firing sequences repeatedly until the procedures became automatic reflexes. The goal was to launch all missiles within 90 seconds of target detection, then retreat at maximum speed exceeding 35 knots before enemy missiles arrived. Every second counted in the compressed timelines of missile combat. A Styx missile traveled at approximately 300 meters per second after boost phase. At 40-kilometer range, Israeli boats had 2 minutes and 20 seconds from initial detection to impact. They needed to detect targets first through superior radar watchkeeping, launch missiles accurately despite time pressure, and begin evasive maneuvers within that narrow window. Failure meant destruction. Lieutenant Commander Michael Barkai, Yosef's younger brother by 3 years, commanded NSA Mivtak and became one of the Israeli Navy's premier missile boat tacticians. He had developed innovative tactics through countless exercises, war games, and simulations. "We operate like aircraft rather than traditional surface combatants," Barkai explained to new commanders during tactical conferences held monthly at Haifa. "Maintain radar discipline until attack to avoid revealing our position. Sprint to firing position at maximum speed. Launch missiles. Sprint away immediately. Never stay in one place longer than absolutely necessary." The ocean is three-dimensional if you consider radar horizons and atmospheric effects. Use weather fronts, darkness, and coastline radar clutter for concealment. Think like fighter pilots, not ship captains. The crew compartments were cramped beyond anything acceptable in conventional naval vessels. Missile boats had no space for proper bunks due to equipment volume. Crews slept on deck when weather permitted or in equipment spaces wedged between machinery when conditions forced them below. The galley consisted of a single hot plate and a small refrigerator, adequate for heating rations, but incapable of preparing proper meals. Sanitation was primitive, with a single head for crews of 20 to 25 men, creating hygiene challenges during extended patrols. Fresh water was severely rationed. Climate control was non-existent. Mediterranean summers made below-deck spaces unbearably hot, with temperatures exceeding 40 degrees Celsius. But these boats could do something no other Israeli vessel could accomplish. They could kill destroyers and fight Egyptian missile boats on equal terms. October 21, 1967, marked the first limited combat test of Israeli missile boats in actual warfare. Egyptian destroyers shelled Israeli positions in the Sinai Peninsula, using their long-range 130mm guns with impunity from positions in international waters beyond the range of Israeli coastal artillery. 3 Israeli missile boats sortied from Haifa to intercept the Egyptian force and demonstrate the new capabilities. This was the scenario Barkai had envisioned 2 years earlier when first proposing the missile boat concept. Fast boats with long-range missiles engaging heavy warships beyond gun range, in conditions where traditional naval combat favored the larger vessel. At 2300 hours, Israeli radar operators detected the Egyptian formation conducting bombardment operations. 2 destroyers positioned 12 kilometers offshore, making 20 knots north along the Sinai coast, while firing their main guns at pre-planned coordinates. The Israeli boats approached from the north, using coastal radar clutter created by terrain features to mask their approach until reaching 16-kilometer range. The Egyptians were focused on their bombardment mission and not maintaining optimal radar watch, a tactical error that would prove costly. Lieutenant Commander Michael Barkai commanded the attack from INS Mivtak, coordinating with 2 other boats through brief radio transmissions using prearranged code words. At 23:15, all 3 boats fired simultaneously in a coordinated salvo. 8 Gabriel missiles launched within 40 seconds, their solid rocket motors illuminating the night sky with brilliant exhaust plumes visible for kilometers. Egyptian radar operators detected the launches immediately. Warning alarms sounded throughout both destroyers. The destroyers turned hard to starboard at emergency full rudder, increasing speed to 30 knots and activating jamming systems that filled radar frequencies with electronic noise. 4 missiles locked onto the nearest destroyer, identified by Israeli intelligence as the Egyptian ship Ibrahim al-Awwal, a British-built Z-class destroyer acquired after World War II and upgraded with Soviet electronics. 2 missiles missed, confused by sophisticated jamming and chaff that the Egyptians deployed with practiced efficiency. 1 missile struck the destroyer's superstructure above the main deck, detonating against the radar mast in a massive explosion that destroyed fire control systems and killed 6 sailors instantly. The 4th missile struck the aft funnel, rupturing steam lines, but not penetrating the armored hull. Superheated steam vented across the aft deck, causing additional casualties. Ibrahim al-Awwal was damaged but not sunk. Her hull integrity maintained despite significant topside damage. The destroyer retreated toward Port Said under reduced power with 1 boiler offline, escorted by the 2nd destroyer, which had not been hit. Israeli boats did not pursue into Egyptian coastal waters, where they would face land-based anti-ship missiles and air attack. They had achieved the primary objective, demonstrating that small missile boats could damage destroyers beyond gun range, fundamentally changing the naval balance in the Eastern Mediterranean. Naval warfare had fundamentally changed in the space of 4 minutes. The engagement sparked intense debate within the Israeli Naval Command and Defense establishment. Critics argued that 8 missiles to damage 1 destroyer represented poor cost-effectiveness, given that Gabriel missiles cost approximately $50,000 each at the time. Supporters countered that forcing Egyptian destroyers to retreat from Israeli coast and terminating a bombardment operation was strategic victory, regardless of precise damage assessment or cost calculations. The psychological impact on Egyptian naval commanders was significant. They could no longer operate with impunity in international waters. Israeli boats were now legitimate threats, requiring respect and defensive measures. Admiral Ben Nun ordered continued development and expansion of the missile boat program. More boats under construction, better missiles with improved guidance and larger warheads under development at Raphael. Improved tactics, refined through systematic analysis of the October engagement. The Egyptian Navy had to respect Israeli missile boats as legitimate threats capable of inflicting damage on major surface combatants, which was itself a fundamental transformation from 6 months earlier, when Israeli boats couldn't engage beyond visual range and represented no threat to Egyptian destroyers. By June 1969, Israeli missile boat strength reached 12 operational vessels, with another 8 under construction or in final fitting out. The Gabriel missile had been upgraded to Mark II configuration with improved guidance algorithms using primitive digital processing and a larger warhead of 200 kilograms. Fire control systems had been refined through hundreds of training exercises and several minor engagements, with operators developing intuitive understanding of radar operations and missile tactics that exceeded anything achievable through classroom instruction. Crews had developed the kind of cohesion and skill that only comes from shared experience and constant training under realistic conditions. The Egyptian response was predictable escalation through Soviet assistance. They ordered 12 additional Komar and Osa-class missile boats from Soviet naval yards on the Black Sea. Each boat carried up to 4 Styx missiles with longer range than Gabriel Mark II. Soviet advisors established comprehensive training programs in Alexandria and Port Said, teaching Egyptian crews advanced missile tactics developed from Soviet experience and incorporating lessons from the October engagement. The Soviets sent their most experienced officers to oversee training, including veterans of Baltic Fleet operations who understood missile warfare thoroughly. The War of Attrition, the prolonged conflict following the Six-Day War that lasted from 1968 to 1970, intensified throughout this period. Artillery duels across the Suez Canal, air raids deep into Egyptian and Israeli territory, commando operations, and increasingly, naval skirmishes in the Mediterranean and Red Sea, as both sides tested capabilities and probed defenses. Israeli and Egyptian missile boats probed each other's defenses regularly, seeking tactical advantage while avoiding full-scale engagement that might escalate beyond control. Each side watched the other, learned capabilities and limitations, developed countermeasures. The decisive moment came not from carefully planned operations, approved by high command, but from tactical opportunity and operational audacity at sea level. What happened next would demonstrate the full lethal potential of missile boats in naval combat and validate Barkai's vision completely. July 16, 1967, 0130 hours, approximately 40 kilometers north of Sinai coast. The Israeli missile boat, Inez Eilat, detected radar contacts during routine patrol operations. 3 vessels identified through electronic signature analysis as Egyptian Komar-class missile boats conducting their own patrol. Standard Israeli doctrine called for boats to retreat when encountering superior forces. 3 Egyptian boats, with 12 Styx missiles, represented overwhelming firepower against 1 Israeli boat with 4 Gabriel missiles. The mathematics strongly favored disengagement and reporting contact to headquarters for evaluation. Lieutenant Commander Yitzhak Shoshan commanded NES Eilat. He had helped develop missile boat tactics, working with Michael Barkai, and understood the mathematical realities thoroughly. Israeli doctrine emphasized concentration of force as a fundamental principle. Never engage when significantly outnumbered. Preserve force for favorable engagements. But Shoshan also understood opportunity when circumstances presented it. 3 Egyptian boats in international waters, far from air support or reinforcement. Night conditions favoring surprise. If Israeli boats could coordinate a surprise attack from multiple bearings, they might achieve tactical advantage through speed and surprise rather than numbers. Shoshan radioed Haifa Naval Base using encrypted burst transmission that lasted less than 3 seconds. 2 additional Israeli missile boats, INS Misgav and INS Miznek, were 15 kilometers south, returning from separate patrol areas. They could rendezvous at attack positions in 20 minutes if they sprinted at maximum speed. The critical question was whether Egyptian boats would remain in their current position long enough to allow coordination. If they detected Israeli boats and retreated toward Egyptian waters, the opportunity would be lost. Commander Barkai, now promoted to staff positions in coordinating operations from naval headquarters in Haifa, made the tactical decision, after consulting with Admiral Ben Nun, all 3 boats would attack. Despite numerical disadvantage in missiles, they would approach from different vectors to divide Egyptian defensive fire and create multiple threats. They would launch all 12 missiles simultaneously in a coordinated salvo, saturating Egyptian radar and jamming systems. It was the tactic they had practiced extensively in exercises, but never executed in combat against peer opponents with equivalent capabilities. At 0150 hours, 3 Israeli missile boats reached designated firing positions, forming a rough triangle around the Egyptian formation. Shoshan commanded from INS Eilat at bearing 045 degrees magnetic, 16 kilometers from the Egyptian formation. INS Misgav, positioned at bearing 135 degrees, 14 kilometers range. INS Misnak held bearing 270 degrees, 15 kilometers distance. The geometry created overlapping fields of fire from 3 directions separated by roughly 90 degrees each. The Egyptians had detected Israeli boats on radar approximately 10 minutes earlier, but could not determine exact positions through the clutter of false returns created by Israeli electronic warfare systems. Their radar screens showed multiple contacts, some representing real boats, some chaff clouds, some electronic false images from Israeli jammers broadcasting deception signals. Egyptian commanders were uncertain whether they faced 3 Israeli boats or 7, uncertain of exact ranges and bearings, uncertain whether to attack or retreat. At 0155, all 3 Israeli boats fired in precisely coordinated sequence, timed by synchronized watches. 12 Gabriel missiles launched within 30 seconds, their rocket motors creating brilliant trails across the night sky. Egyptian radar operators saw 12 incoming missiles converging from 3 directions simultaneously. Their doctrine called for coordinated defensive fire using rapid-fire 30mm cannons, effective against missiles at ranges under 2 kilometers. But the missiles were approaching too fast from too many angles for effective defensive coordination. The first Egyptian boat, attempting to launch its own Styx missiles in counterattack, was struck by 2 Gabriel missiles within seconds of each other. Both missiles hit the port side, penetrating the thin-hulled vessel and detonating inside the crew compartments, where they created devastating blast effects in confined spaces. The boat exploded catastrophically, ammunition and fuel cooking off in a series of secondary blasts that sent debris hundreds of meters into the air. The vessel sank in under 3 minutes. All crew killed instantly or went down with the vessel. The second Egyptian boat managed to launch 1 Styx missile toward the approximate position of INS Misgav before 3 Gabriel missiles converged on its position from different bearings. 1 missile missed by less than 10 meters, passing over the boat. 2 struck the superstructure and hull simultaneously, 1 penetrating the bridge and 1 striking amidships at the waterline. The boat did not explode immediately, but was catastrophically damaged, taking water through multiple hull breaches. The crew abandoned ship in panic. The vessel sank within 8 minutes, settling by the bow. The third Egyptian boat turned to retreat toward Egyptian waters at maximum speed, exceeding 35 knots, but was struck by 2 missiles in the stern section. Both missiles detonated against the engine room, destroying the main engines and auxiliary systems. The boat went dead in the water, burning intensely as fuel fires spread through the hull. Egyptian rescue vessels dispatched from Port Said arrived at dawn and found survivors clinging to wreckage and debris. Of 3 Komar-class missile boats, representing significant capital investment and crew training, 3 were sunk within minutes. Estimated casualties exceeded 70 sailors killed or missing. Israeli boats suffered no damage whatsoever. The 1 Styx missile launched by Egyptian boats had been successfully decoyed by chaff clouds and missed its intended target by over 2 kilometers, splashing harmlessly into the Mediterranean. The engagement lasted 4 minutes from first launch to final detonation. 12 missiles fired, 9 direct hits achieved, 75% accuracy under combat conditions. 3 missile boats sunk with total loss. It was the most successful missile boat action in naval history to that date, and remains one of the most one-sided naval engagements ever recorded. News of the engagement reached international naval commands within hours through intelligence channels. Intelligence agencies worldwide demanded detailed information. How had small Israeli boats sunk 3 Soviet-supplied missile boats? What technology enabled such devastating accuracy? What tactics overcame numerical missile disadvantage? What did this mean for surface warfare doctrine? The Soviet Navy was particularly concerned and launched immediate investigations. Their Styx missile system, considered superior in range and warhead size to Western equivalents, had been defeated by shorter-range Israeli weapons. The Egyptian crews had been trained by Soviet advisors, using Soviet doctrine developed over decades, yet they had been annihilated in 4 minutes without inflicting any damage. The implications for Soviet naval doctrine and equipment were profound and disturbing. The United States Navy sent observers to Haifa to examine Israeli missile boats and tactics firsthand. American naval doctrine still emphasized gun-armed destroyers and cruisers for surface combat. Missiles were considered primarily anti-aircraft weapons or strategic systems for nuclear delivery. The concept of surface-to-surface missiles on small boats as primary armament was revolutionary and contradicted established American naval architecture and force structure. Captain John Foster, United States Navy liaison to Israeli forces, filed a comprehensive report that circulated through the Pentagon and eventually reached the Chief of Naval Operations. Israeli missile boats represent paradigm shift in naval warfare, with implications that extend far beyond the Middle East. Small, fast platforms with guided weapons can engage and destroy larger vessels beyond visual range, under conditions that favor the smaller platform. Traditional advantages of armor and firepower become irrelevant when engagement occurs at 15 to 20 kilometers. Speed, surprise, and first strike capability determine outcomes rather than displacement and gun caliber. The implications are profound and require reassessment of American surface warfare doctrine. Expensive destroyers and cruisers become vulnerable to cheap missile boats, costing 1/10 as much. Naval combat shifts from gunnery duels to electronic warfare and missile tactics. Recommend immediate evaluation of American missile boat programs and acceleration of surface-to-surface missile development. The report influenced American development of Pegasus-class hydrofoils and later Harpoon missile systems, though implementation took years due to institutional resistance and bureaucratic inertia, similar to what Barkai had faced. Commander Yosef Barkai was promoted to captain and awarded Israel's highest military decoration for valor and innovation. His illegal idea, rejected by naval headquarters just 18 months earlier as technically impossible and doctrinally unsound, had proven decisively correct through combat results. Missiles on small boats could dominate surface warfare when properly employed with appropriate tactics and training. The doctrine spread rapidly through world navies as the implications became undeniable. The Israeli Navy accelerated missile boat production dramatically. By 1970, they operated 24 missile boats, with another 12 under construction, making them proportionally the world's largest missile boat fleet relative to total naval strength. Egypt responded by ordering more Soviet missile boats and increasing crew training intensity. But the psychological impact of July's devastating defeat had lasting effects on Egyptian naval commanders. Egyptian doctrine became increasingly defensive, emphasizing coastal protection rather than offensive operations in international waters. The October War of 1973 provided the ultimate comprehensive test of missile boat warfare. During this conflict, Israeli and Egyptian missile boats engaged in the Battle of Latakia and Battle of Bolton, historically significant as the first pure missile boat battles in naval history, where neither side employed traditional gun-armed warships. Israeli boats sank 5 Egyptian and Syrian vessels without suffering any losses, validating Barkai's concept comprehensively and demonstrating Israeli tactical and technical superiority conclusively. The technological evolution continued relentlessly throughout the 1970s. Israel developed the Gabriel Mark III missile with 60-kilometer range, then later versions with even greater range and improved guidance. Fire control systems became digital, using early microprocessor technology for targeting calculations and threat evaluation. Electronic warfare systems grew exponentially more sophisticated, with automated threat detection and countermeasure deployment replacing manual operator decisions. The SAR 4 and SAR 4.5 class boats, commissioned in the mid-1970s, represented mature missile boat designs, incorporating a decade of operational experience. Displacement 430 tons, length 58 meters, maximum speed 32 knots. Armed with 8 Gabriel missiles, 4 Harpoon anti-ship missiles, Barak anti-aircraft missiles for self-defense, and rapid-fire cannons. Crew 45 personnel. These vessels could conduct independent operations for extended periods exceeding 2 weeks, engage multiple target types simultaneously, and defend against aircraft and missile threats. Cost per boat, approximately $70 million. A destroyer with equivalent offensive firepower cost $500 million or more. The economic calculation was compelling. This economic advantage drove global naval development. Dozens of nations adopted missile boat designs, either purchasing from experienced builders or developing indigenous designs. China developed the Huangfen class, based on Soviet models with modifications. Germany built the Gepard class for Baltic operations. France developed the Combattante series, which became an export success. Even the United States, initially skeptical of small combatants, commissioned Pegasus-class hydrofoils, armed with Harpoon missiles for special operations. The fundamental principle proved universal across different naval environments and operational requirements. Small, fast platforms with long-range missiles could conduct effective naval warfare at a fraction of traditional costs. This democratized naval power in ways that had profound geopolitical implications. Nations that could never afford destroyer fleets could operate credible missile boat forces capable of defending territorial waters and challenging larger navies in littoral environments. Regional naval balances shifted worldwide as smaller nations acquired capabilities previously reserved for major powers. The engineer who made all this possible remained characteristically modest throughout his career and retirement. Captain Yosef Barkai retired from the Israeli Navy in 1982 after 30 years of distinguished service. He refused media interviews and avoided public attention carefully, insisting that missile boat development was a collaborative team effort involving hundreds of engineers, tacticians, and sailors whose contributions were equally important. But those who worked closely with him understood his unique contribution. Barkai had recognized that technology could overcome doctrine when institutions were too rigid to adapt. He had understood that weapons platforms were not fixed categories, defined by tradition, but flexible tools that could be adapted to new purposes. He had persisted despite overwhelming institutional resistance because he trusted engineering analysis and mathematical proof over tradition and hierarchy. Lieutenant Commander Michael Barkai, who commanded the first successful missile boat attacks and went on to become a rear admiral, wrote in his memoir, published in 1995, "My brother saw what others couldn't imagine because they were blinded by tradition. He understood that a missile doesn't care about the size of the ship that launches it. The missile has its own propulsion, its own guidance, its own warhead. The launch platform merely provides initial velocity and targeting information." He proved that creative engineering and innovative tactics can defeat tradition and institutional hierarchy. That lesson applies far beyond naval warfare. Modern naval combat remains dominated by missile systems that trace their conceptual lineage Directly to Barkai's innovations. Anti-ship missiles have evolved into supersonic and hypersonic weapons, with ranges exceeding 300 kilometers. But the fundamental principle, established by Barkai in 1967, remains unchanged. Speed, range, and first strike capability matter more than platform size. The Israeli missile boat program demonstrated that asymmetric warfare applies to technology as much as tactics. You don't need the biggest navy. You need the smartest application of available technology. In the Mediterranean, where Israeli missile boats first proved their worth, modern vessels continue patrols, using descendants of the systems Barkai pioneered. The Komar-class missile boats, sunk in July 1967, rest on the seafloor. 3 Soviet-built vessels, destroyed by a weapons system their designers never anticipated facing. The ultimate ship killer was not a massive battleship or advanced destroyer. It was an idea, considered illegal by those who couldn't imagine alternatives, proven correct by an engineer who understood that innovation requires challenging truths everyone else considers self-evident. One engineer's persistence transformed naval warfare permanently, proving that strategic revolution often begins with tactical innovations that established powers initially reject as impossible.